Find the derivative of y equals sine to the fifth of t divided by 4t minus 1, then evaluate y prime of pi over 2. Y here is the quotient of two functions, the sine to the fifth of t over 4t minus 1. Therefore, the derivative is going to involve the quotient rule. Before we take the derivative, let's rewrite that numerator as sine to the t to the fifth. Remember that it means to work out the sine first and then raise to the fifth power. It's a good idea to write it that way to show us how to take the derivative of that term. We will need that for the quotient rule. The derivative, y prime or dy dt, will be found by the derivative of the numerator. We have a quantity to the fifth power. We'll start with the power rule. Bring the power down, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside. The derivative of sine of t is cosine of t to complete the chain rule. Derivative of the numerator times the denominator left alone, so 4t minus 1 left alone, minus the numerator left alone times the derivative of the denominator, which is a 4. The entire thing over the denominator squared, so 4t minus 1 quantity squared. So I'm just going to rewrite this. For the first term, I'm going to move the 4t minus 1 to the front with the 5. So we have 5 times the quantity of 4t minus 1. I won't distribute the 5 in. And then we have a sine t to the fourth, or sine fourth t, cosine t. And we have a minus, I'll put the 4 in front, and then sine t to the fifth can be written as sine fifth of t, all over that denominator, which is 4t minus 1 quantity squared, and I'm going to leave that alone. So there's our derivative y prime or dy dt. The only other thing that we can do with that is factor out a power of sine. We actually have a sine fourth of t in the first term and a sine fifth of t in the second term. We can factor out the lower power of the two. So y prime or dy dt will be factoring out sine the fourth of t. For the first term, we're going to be removing all 4 of those, so that will take all of that out. For the second term, we're going to take out 4 of the 5, and that'll leave that. So there's what should be left over after the factorization. So we have 5 times 4t minus 1 times all that's left is a cosine t for that first term, and then minus 4, and all that's left is sine of t for that second term. And all of this is divided by 4t minus 1 quantity squared. So there's the factored version of the derivative. The next thing to do is evaluate y prime of pi over 2. That means to plug a pi over 2 in for each of the t's. So that will give us sine to the fourth of pi over 2 times the quantity of 5 times 4 times pi over 2, 4 pi over 2, minus 1, cosine of pi over 2, minus 4 times sine of pi over 2, and then all of this divided by 4 times pi over 2, which is 4 pi over 2, and then minus 1 squared. That first expression, that's sine to the fourth of pi over 2. Now that means to evaluate the sine first and then raise it to the fourth power. In here we have 5 times, now this is 4 pi over 2, and that 4 and that 2 can reduce, so that'll just reduce to 2 pi minus 1. And then the cosine of pi over 2, which is a 0, minus 4 times the sine of pi over 2, which is a 1. All this over 4 pi over 2, which can reduce to 2 pi, and then minus 1, and then quantity squared. So y prime of pi over 2 equals to sine of pi over 2 is a 1, So we have 1 to the 4th, and then we have in brackets here, all of this is multiplying with 0, so all of that will just be 0. And then we have minus 4 times 1, which is negative 4. And then all of that over 2 pi minus 1 quantity squared, which I'm just going to leave the way it is. In the numerator, 1 to the 4th is 1. 0 minus 4 is a negative 4. And then all over the 2 pi minus 1 quantity squared. 1 times negative 4 is negative 4. And we'll just leave the denominator alone. Negative 4 over 2 pi minus 1 quantity squared.